So this is easy. So Cp is given by this equation. So you have been given Cp. Are you getting? Now find the expression for amount of heat required to raise the temperature of 1 mole of gas from T1 to T2. So you remember we have defined what is the definition of Cp. So Cp is 1 by N and this is dq by dt at constant pressure. This is equals to Cp. This is the definition of Cp, if you remember. Now if I use this definition for n mole of 1 mole, so that is given in the problem, we can write dq is simply Cp dt, and then I can integrate this one. So I will have dq is equals to Cp is what? Cp is given a plus bt. So 3 term you have a plus bt plus ct square plus dt cube, and this multiplied by dt, and then you integrate this one. So let us say if you do this integration, dq will be a t so ctq by 3 plus, now this is d, so this is the integration. Are you getting? So expression for amount of heat required to raise the temperature of 1 mole from T1 to T2. So we have to integrate this one from T1 to T2. So we have to do different integration from T1 and this goes up to T2. I can put the same thing here. So this is from T1 to T2. So this dq, now I can write this is a T2 minus T1, and similarly you can write the rest of the term b by 2 T2 square minus T1 square and plus c by 3 minus T1 cube plus d by 4, and this time we will have t to the power 4 minus T1 raised to the power 4. So this is the dq. Now the b part of the question says, oh, this is the part 1, keeping the first term and then keeping the first 2 terms. So you have to special cases. So the part 1, keeping the only first term. So this means you have to keep only this term. So in this case dq will be a T2 minus T1. Now in the part B, keeping the 2 term, so you have to have from here to here. Are you getting? So these 2 term you have to keep. So this means this term dq will be a T2 minus T1 plus b by 2 T2 raised to the power 2 minus T1 square. Now the part C of the question says, this says keeping all the terms of the expression, this each successive terms introduces higher accuracy. Of course, you see, if you introduce this term and this term, you will have more accurate than this term. If you will include this term, if you include this term, your answer will be more accurate. If you include even this term, your answer will be more refined. So you are adding more term, more refinement. Now next is for CO2, A, B is given. Find the heat required from 300 to 500 Kelvin. So T1 is 300 Kelvin and T2 is 500 Kelvin. So I have to go from T1 is 300 Kelvin. Now this is only calculation, and T2 is 500 Kelvin. And value of A and the value of B is given. So the A is 5 and B is 15 into 10 to the power minus 5. A is 5 and V value is 15 into 10 to the power minus 5. Let me check. Yeah, this is the 15. Now we have to calculate what is the value in both cases. So let us say I can write dq in first case. Dq, that is A into T2 minus T1, A is 5 and T2 minus T1 is 200. So this is 5 into 2, 10. So you will have this much amount of joule that is required, or you can say 1 kilojoule. I have to look whether Cp is given in kilojoule or it's in kilocalorie. So let us see. Yeah, Cp is given in calorie per mole per Kelvin. So Cp is in calorie. So Cp is in calorie. So this value is a calorie. So 1000 calorie. So I have to rub this one. So this is in calorie. And this becomes kilocalorie. Are you getting? Simple. So this is a calorie value and this is 1 kilocalorie. Now we can calculate the same thing using the second expression. I will have more refinement. The first term is same, this term is same, that is a 1 kilocalorie is same. So 1 kilocalorie value is same, plus B by 2, B is 15, so this is 7.5 into 10 to the power minus 5. And then I have to a square, T2 a square, that is 500 a square, so 2, 5 and 40. Minus T1 a square, that is 9 into 40. So this value, you can do this calculation, easy one. So this is 1 plus. And now if I divide this by 1000, then I will get in kilocalorie. This is in calories, so I have to divide by 1000 so that I can directly add. And this is, this 30 goes, so 1, 2, 30 goes. So you will have 160. So this is 160. So you will have 1 plus. Now even you can eliminate this 0. So 7.5 into 0.16 into 10 to the power minus 3. Now let us use the calculator. So I will have 7.5. This multiplied by 0.16. So this value is 1.2. So 1.2 into 10 to the power minus 3. So this value is 1 plus 1.2 into 10 to the power minus 3. So this means 1 plus 0.0112. Are you getting? So if you add these two things, so you will have 1.0112 kilocalorie. So this is the final value we have. Let us check the answer. Yeah, you have 1012 calorie. So that is, if you multiply this by 1000, so you will have around 1011.2 calorie, approximately equals to 1012 calorie. Now what is the error we are doing? So you see, if you use the first method and you use the second method is more accurate. So we will assume the second method is true method. So what is the error? So in the second method I am getting 1.0112 kilocalorie. In the first method I am getting 1. Are you getting or not? So you see here, in first method is 1. And this should be divided by true value, more true value. Basically this is also not 100% true, but this is more true, 0.112. So this value will come, and this multiplied by 100, so I will get in percentage error. So this is the percentage error. So you will have 0.0112 and this divided by 1.0112 into 100. So what is the percentage? So let us check this one. 0.0112, this divided by 1.0112, and this multiplied by 100. So this is 1.2. So this is around 1.2%. Let me check again. So this value is 0.0112 and this divided by 1.0. So this value is, I think there are some mistake I am doing. It cannot be 1.2. So this expression is not good. So this value is 0.0. So let me multiply. So 0.011. So this is 1.107. So this value is around 1.107%. So this is the percentage error, but this is exact, not exact percentage error. Are you getting? If you want to find exact percentage error, then you have to find exact value. That is, you have to calculate C2QI3 dt 4/4, but CD is not given. Are you getting or not? In this problem, C and the value of C and D is not given. So if you want to find exact value, then you have to find C and D and put the value, and then you will get the exact value. So you will have 1.107 and the answer you have 1.18%. That is around 1.107. This answer is different because the value of C and D is not given in the program. If I give you the value of C and D, you will get this exact answer. Are you getting or not?